Hey guys, how you doing? It's Coach Scott, and our next to last video on the ionic compounds unit, right? Today we're going to be talking about naming ionic compounds, which is a skill we need to do. Knowing how to name. We've already started doing some of that in the previous lectures. All right, so when we name an ionic compound, and this is almost a review for some of you, but well, for everybody it should be because we covered it in at 4C. So when we name a binary ionic compound, and binary means it's a two-part. There's two components to this particular type of ionic compound. We've got a cation, of course, and an anion, right? So most of your cations will have the name of the element, and that's what you call it, right? So we have the hydrogen ion, H plus, lithium, potassium, cesium, and silver. And silver, just know that it's going to be 1 plus. There's no variation on that, but you just call it what it is. Easy. You got the plus 2 cations: magnesium, calcium, barium, and cadmium, and the major 3 plus cation is aluminum, and it's aluminum, right? Now the anions, the trick on this is whatever the atom's name is, drop the suffix, the last part of the root word, and add IDE, right? Now if you notice the ions of group 17, all right, we call those the halides. Who can guess why we call them halides? Well, because we have halogens, right? It's the name of the group. Get rid of the ogen and add IDE, then you have halides. All right, so your group 15, instead of nitrogen, you have nitride. Phosphorus, drop the O, your orus, and you're going to have phosphide, add IDE. Oxygen, oxide, sulfide, sulfur, sulfide. Then you got the 17s, the halides, fluoride, chloride, bromide, and iodide. Just is what it is. All right, so these two element compounds, we write the name. We start with the cation first, the metal, and then we follow it with the anion. All right. So if we have NaCl, okay, we have sodium, name of the metal, chloride. Ki is potassium iodide. Li2S, okay, we talked about how we did that in 4C, 4D. Lithium sulfide. Not hard. So what are we going to call Na2S? If you think about it, take a break. And of course, that is going to be B, sodium sulfide. SRO, what would that be? Think about it. Break. That's going to be strontium oxide A. Al2O3, that's going to be break. That is going to be D, aluminum oxide. So those other names in there, if it was a covalent compound, we'd be using those. But this is a ionic compound. It's just aluminum oxide. D. So let's talk about our transition metals, those D block metals. So remember that S block metals and some of those P block elements like aluminum have only one possible ionic charge based on the octet rule. Okay. Most transition metals can have more than one ionic charge. So we have a system for designating the charge on each ion. Now there are some of the P blocks, which we call the post-transition metals, and there's metals that are after the D block, and that's why we call them post-transition metals. Think tin, lead. Those are, you would think would be metals, and they are. They can also form more than one type of ion, and they can behave like transition metals, or they do behave like transition metals, mainly because they have that D block to put and take away electrons from. So, and I'll put this sheet in your notebooks. I know, I promise, but I'll get it in there by next week. But this is a chart on some common cations for some of the transition metals. You can see that scandium, well, you can see that there's a whole lot of 2+ charges out there. Vanadium, chromium, manganese, iron, cobalt, they can all be 2+. Think about it. Why? Well, all the transition metals have that S, that 2-electron S orbital, right? Before they get into the D's. So they will lose those a lot of the time, right? And they'll lose those before they'll lose the electrons in the D block, okay? So a lot of that is just memorize them. So these are some of the other cations in a different type of chart configuration. You've got copper, mercury, and silver. Those are 1+. Cadmium, chromium, cobalt 2, copper 2, iron 2, lead 2, mercury 2, manganese 2, and tin 2. Those are 2+. You might see a pattern here with the Roman numerals coming up. Then you've got chromium 3, cobalt 3, iron 3, manganese 3. Those are all 3+. And of course you have lead 4 and tin 4. And those are 4+. Right? Now, silver, cadmium, and zinc are cations that will only form one cation. Silver will be +1. Cadmium and zinc will be 2+. Now, of course, tin and lead act like transition metals, and they're going to share two common charges, +2 and +4. And if you think about it, why that's true? Well, because most of those have those 2 p electrons, and they got 2 s electrons, so they'll lose two of those or 4 of those. Now, why do these ions only have this one possible charge, silver, zinc, and cadmium? If you look at the d orbital, all right, of both zinc and cadmium, they're full, all right, and they're stable. So these electrons are only going to lose those 2 s electrons because there's so many of those. There's the 5 d orbitals, and they're filled. It would be more unstable for that atom to lose a couple of those out of the d blocks. So it's easier for it to go ahead and lose those 2 s electrons. All right. If you look at silver, it's full. All right, because it's taking an electron from its own s orbital to make it a stable 10 electrons in the d orbital. So it's only going to lose that 1 s or electron, and that's why it's got a +1 charge. Okay, so if you look at these, we're going to use those Roman numerals. It's something called the stock naming system to name these transition metals. All right, you can see that with copper +1, we're going to call it the copper 1 ion. Cobalt +2 is the cobalt 2 ion, and that's how you say it. Chromium +3, we're going to call it the chromium 3 ion. We just put the number there, the Roman numeral. What would be copper 2 plus? Well, it's going to be copper Roman numeral 2. Manganese +7 is going to be manganese 7 in Roman numerals. And that's how we use it to name it. All right. So this is how we write the charge on the cation. All right. These are actually easier than just normal binary or things on the p block. We have to actually look at a periodic table. By saying this is iron 3, right? Whoop. By saying this is iron 3, this should automatically write. Let's see. Yeah, there we go. By saying that is iron 3, that tells me I know that's going to be a +3 charge. Okay. Oxygen is pretty easy. Look at it on the periodic table. You'll eventually memorize that's going to be 2-. So I've got the iron is +3. I got it through the name. I do the crisscross because I like crisscross. Put a 3 there and a 2 there, and you come to a compound just like that. That gives us a ratio of the cations to anions. That is already reduced as much as you can, the 2 and the 3. So our iron 3 oxide is Fe2O3. Now, we've got to make sure that we have to reduce those to the lowest common or lowest whole number ratio. So this is a compound 10,4 oxide. Well, they gave me the charge right there. It's plus 4, 10,4. Good, buddy. So 10,4 oxide, look at the periodic table, is 2 minus. There it is right there. So now we're going to crisscross it. 4, 2. So I've got 10,2 oxygen 4. 10,2 oxygen 4. Okay. That's not the lowest whole number ratio, is it? I can divide everything by 2, and it's going to come up with SN1 O2. And that's what we're going to write, SnO2. One's understood. So, which of these metals are capable of forming more than one cation? That's group 1. That's group 1. They're not going to do anything but group 1. I think barium is group 2, so it's not going to form more than one cation. Of course, that is D10. All right, which metal is not capable of forming more than one cation? It said not capable. So we're looking for something that is either going to be in group 1, group 2, group 13. There's a hint. Copper, transition metal, it can do more. Gold, AU, it can do more than one. Iron's transition, the only one that's not is D, aluminum. And that is the answer. So, in order to correctly name a formula with a transition metal, we've got to first determine what the charge is on the cation. Now, all compounds are neutral, all right? So that means the total positive cation charge must equal the total negative anion charge. So, cation charge plus anion charge is going to be 0. So whatever the charge is of the cation plus the number of cations times the number of cations plus the charge of the anions times the number of anions is going to be 0. All right, so let's look at it this way, and then I'm going to show you how I do it. So I've got iron FeCl3. So we're going to substitute what we've got. We do not know the charge of the cation. If we don't know something, what do we put down? Oh, we're going to put an X, right? A variable. We do know that I have one iron cation, Fe cation, so I've got a 1 right there. All right. The charge on chlorine. Well, that's pretty easy. I look at the periodic table. It's in group 17. I know that it's going to be -1. I've got 3 chlorine, so that's going to be X plus or -3 equals 0. So if I solve for X, X minus 3 equals 0. Solve for X, that's going to be plus 3. So X is equal to 3. So that means that the cation is Fe plus 3, or we would write iron Roman numeral 3. Not bad. Another way of doing this is how I do it. So we're going to use that formula, right? I've got Fe1Cl3, all right? Another way of doing this is if I've got FeCl3, all right? Don't know what that is. I know that's 1. So I know that Cl is -1. I know that's 3. So if I'm going to do a reverse crisscross. So 1 to minus up there. All right, then I've got my 3 there. So that means that has to be plus 3. All right. That's the ratio of doing it, or the reverse crisscross method, I call it. Either way that works for you is just fine. All right. So the ratio is 1 to 3. Okay. So that means the charge of the iron has to be 3. I like the reverse crisscross better. All right. Here's another practice. CrO. Okay. That's a 1-to-1 ratio. Oh, I know that really oxygen is -2. We got a 1-to-1 ratio. That means chromium has to be +2. So that has to be chromium 2 oxide. So the correct name of the compound V2O3 is vanadium 2 oxide. Well, let's look right there. That can't be right. So I know that's -2. I can call that X. Or if I know that's 2 and that's -2, I can do a reverse. That's got to be +3. If I do a reverse crisscross method, so the V, that can't be right because it's vanadium 3 oxide. So that would be false, and indeed it is. The correct name for copper Cu3N is what? Well, let's do the Cu3N. N I know is -3. So I'm going to do a reverse crisscross. That's got a 1, so that's got to be copper +1. All right. I like the reverse crisscross method. It works for me. That's B. That's how my mind thinks. Sorry. The name of iron, or FeCl3. Once again, FeCl3. That's got to be a -1. There's a 1 there, so that has to be +3 by going back like that. So that is going to be iron 3 chloride. That's going to be C, and indeed it is. The correct formula for tin-4 oxide. Okay, so I know tin is SN. It gave me tin-4, so I'm going to write +4 on there. It's oxygen. Well, if I look at the periodic table, or I just know it, it's -2. Do the crisscross method. 2, 4. All right, 10 SN2O4. I can get that to a little bit more of a lower whole number ratio. Divide everything 2 by 2, everything through by 2. That's going to be SN1O2. That's going to be what? It's going to be A. Copper 2 sulfide. And we'll work these out, of course, in class. So it told me that copper has got a +2 charge, and then sulfur has got a -2 charge. -2. Take those down, crisscross. So lowest number ratio is 1. So that's going to be CuS. CuS. Got to practice these, but it's really not that hard. Which one of the following compounds is copper 1 chloride? Copper 1 chloride. So I said it's Cu, it says copper 1, so that's going to be a +1. Why? Because of that. All right. Chlorine, if I look at the periodic table, it's got a -1. Oh, this is going to be easy. Crisscross, CuCl. And of course that should be A, and it is. Whew, the charge on the cation in the salt, Fe2O3. We're going to change our definition of what a salt is. All right, but this is 1. Let's do it. Fe2, and it's looking for the charge, the charge on the cation. All right, so the cation is the iron, so that's what we're worried about. I know oxygen is -2. I could put an X there. I don't need to. I said -1, -2. Reverse crisscross, reverse crisscross. That has to be a +3. And indeed it is. Ooh, what's the charge on zirconium ion in ZrO2? Zr? Don't know. Oxygen? Don't know. And it said 2. Well, I know oxygen is -2. It's got a 1 there. So that means reverse crisscross. That means it was really a 2. If I made that a 2, that means I multiplied that 1 times 2. That means I need to multiply this by 2 to get 4. So I put the 4 up there. That means it's got to be a +4. Zirconium's a +4. Let's see if I'm right. And indeed I am. Okay, guys, we've got lots of practice here on how to write the formula of the transition metals and the binaries, and we need to practice them because it is a skill that you just have to learn to do. And the only way to do it is by practice. Okay, guys, this is Coach Scott saying have a good evening, and keep studying on that chemistry and doing all the great things that you guys are doing. All right, this is Coach Scott saying toodles.